She has a microphone problem.
Okay, so it's live.
Okay, I'm going to share my screen. See how this works. Okay, can you see it yet?
Yeah, we can see
I
it.
don't know how good my internet is tonight. It seems to be a little slow. Okay, so we're going to talk about in 5 minutes or less. Can you still see it?
Yeah.
Okay. Local storage. Um, local storage had its roots probably, um, with cookies. Everybody's heard of cookies. Probably in some of your classes you had to create and retrieve cookies. Well, that's kind of an early version of local storage. Um, so what do we use local storage for? Well, you want something that is fast, and nothing's faster than your local storage. And one advantage,
We stopped seeing your screen, Dan.
okay, hold on. Let me, can you see it now?
Yeah.
Okay, let me do it this way then. See if that works. So you should see why local storage. Is that where you are?
Yeah.
Very good, okay. The idea of local storage is not new. It's gone through a couple of different names. It's actually a specification of HTML5, and we like it because you can do stuff with it. For example, if you wanted to keep track of something between sessions, in other words, if you had, for example, you had a website that the user could customize the colors or the background or something silly like that, then local storage would be something that you would do because you could persist it between sessions. And so when the user came back to your website, it would look like it did when they customized it and left. If you're a Windows user, you've probably dealt with registry and INI files and things like that. That's another way a program that usually is running on the client can keep track of things that are needed between sessions. So cookies, we already talked a little bit about that. Cookies have a number of problems. And one of the biggest problems is they're not very secure, and they have a limit of how big you can make it. And cookies typically are included when you do every request. So even if you've got something on your machine and you go to that website, it's still going to go out there and look at it. So it potentially slows things down. So it was determined that cookies really aren't enough. And like we talked about earlier, you need more storage space. You need something that is not constantly hitting the server for something. And you need something that's more secure. Cookies are none of those things. So even though we still hear about cookies and we still use cookies, for any more sophisticated than that, they're really not enough. So HTML5 spec specifies there's a bunch of different names. You might hear just local storage. You might hear web storage. You might hear DOM storage, depending on who wrote the article. they're all the same thing. So when they actually came out with this spec, they've got a standardized API that all the browsers can use, and believe it or not, most of them, even all the way back to IE8, use this specification. So you can be fairly confident that your code for local storage will work across browsers. Now, if you've got IE7, then you've got problems. More than just the local storage problem. So there's application support across iPhone, Android, which makes it usable by almost everybody, right? So you can be confident sort of that your application, your website will work across browsers. So this little piece of code up here is just one method of checking whether the browser that your web page is being rendered by supports local storage. It's not the best way, but it is a way. Many people like to use the Modernizer plugin to do a whole bunch of things, and one of the things that it can do is verify whether local storage is available. So there's some methods that you can use for local storage. It's fully supported in JavaScript as well. So here's an example using this particular way of doing things. You can check, you can see if it's using it, you can do all kinds of stuff. And even, you know, when you look at we'll look at this. There's a bunch of storage events. You remember last week when Bart was talking about the different events in the DOM. Well, all of those things are accessible also with this storage event. You can use that sort of walking through the DOM tree and doing things to do your storage. So it's not perfect, but it's a lot bigger than the cookies. You know, right now, 5 megs of storage from each web page that you put up there. So that's plenty to do a lot of stuff. There are limitations, one of which is you can't ask for more storage. Opera has a sort of a workaround for that, but I honestly don't know a whole lot of people that use Opera, except maybe on Android or something. So this website I have up here, I have this URL, Can I Use, is a really good resource to check a lot of stuff across all the browsers. And you can look for example, local storage support, and that site will tell you what versions and how well it's implemented and all that. It's a really good website. So I'm going to try to do a little demo here. So I'm going to stop sharing my screen right now for this particular thing, and hopefully this will only take a few minutes because I know we're running along. Let me switch over to this little demo site. and we'll see if my interweb comes up. Okay, I'm going to share this real quick, and this is really a dirt simple example, and it's kind of blinding. You see all the red? Yeah, it's strictly a demo. So there's this, and if you notice here, can you see my cursor? This section right here, where you make these changes, are persisted using the web storage API. So if you, for example, let me get the sorry, I have to switch a couple of screens here. Are you still seeing my screen?
Yeah.
Okay, so do you see the screen that says event output?
Yes.
Okay, so the way this little demo works is if you have these two web pages, these two tabs open, the one generates the code and persists it. That's this one. And this one, you can see the output. Okay, so the idea is that when I make these changes, such as that, and I can change the font, and I can change the picture, whatever, if I go look over here, you see those things are changed. And that is because this particular page is using the web storage API to persist those items across, and this little website pulls those out of the local storage. So it's just a little demo of how that actually works. Let me. Sorry, I have to go back and forth here. I didn't intend this to be so long, but anyway, there's some code that you can look at up on GitHub, and these things are from the Mozilla website, which also has a really good reference describing the web API. And you know, a summary, the reason we want to use this is because it's fairly standardized across browsers. It's more secure when you store these key value pairs, and it's better than cookies. One of the things I didn't go over, which is part of this web storage API, is you can use it to generate, populate, and read back things from JSON files. So we'll be talking about those at some point. And that's it.
All right. Cool then.
Great.
Okay, if you guys are ready, I'll go ahead with mine.
Go for it.
All right. So, can you guys see my screen?
We can. You.
All right. Okay, if you guys should be able to find this Google Docs document that I put together in our team share about Ajax and what is Ajax. So typical and web applications that use server to to serve content or to do some type of processing, usually when the user clicks on a button or clicks or does some sort of action on the page, for example, in ASP.NET or even pretty much any type of web application, the page would go to the server, do whatever processing on the back end, and then would serve the results. So that would be a callback to the server. Ajax, what it does is make sure that we don't have to deal with that. So it basically removes the need to reload a web page. So what does it stand for? It stands for asynchronous JavaScript and XML. Basically, it uses JavaScript to make any calls to the backend that need to be made to pick up data and then put it back and show it on the screen for the user. There are four benefits for using Ajax in web applications. As I said, you remove the need to perform a callback, so you don't need to do a round trip to the backend. So it improves performance. You're able to make asynchronous calls. So basically, when you're loading a web application, you can make calls asynchronously, so the user is not waiting for the full page to load for data to start showing up on the screen. And if a call is taking too long, the page can load, and when the call comes back with the data that needs to be shown on the screen, it's done asynchronously, so you don't have to wait. The other benefit is user friendliness. So by limiting the postbacks, Java-enabled applications will always be more responsive. So they will always load faster. You don't have to load anything to pick up data or process data on the back end. And improves performance as well. So when you do a callback of a web page, it goes back to the request goes to the server and comes back. You're sending when the page is coming back, it's bringing both the elements that compose the UI, so images, HTML elements, and all that, plus the data that you want to show. So you have additional overhead. When you use JavaScript or Ajax, these JavaScript callbacks, you're only fetching data, so you don't have to deal with all that overhead to load the data. So better performance. I put together a quick example. This example can be found as well in the Tree Schools on the Ajax page. And this is really just a very simple HTML page. Let me actually open it. It's easier to see here. This is a very simple example of an Ajax page. Basically, it's HTML. It has a function called load_doc that basically sends an XML HTTP request, which is basically a method that makes an HTTP request to the backend to an address that you specify and brings you something. In this case, it actually just goes and fetches a file and shows the content of the file on the page and changes the content of the page. Another example that you could use, instead of fetching a file, you could actually be calling a service, another HTML page that would return some type of data that you would want to show on your screen. It would return a JSON object, for example, so that you could process it via JavaScript on your screen. The file ajaxdemo.txt is just a file with some text. So I'm going to call it so that you can see how this example works. As you can see here in the body, there's some text loaded up front, and then there's a button that it's called and calls the load_doc page. Let me go here. So as you can see, we have this just very basic text here, and you do press the button, and then you get the content of the file. There was no post back, no call back. The page didn't go back to the server. It was just a call that went to the server, picked up some data, and showed it on the screen. Very quick, very fast. That's the benefit of Ajax. I put together another example. This is a little bit more complex, and it uses VisualStudio.net. This is for a project that I did a while back. It was just a demo that I was working on. And it's using jQuery, which we're not allowed to use, but I just wanted to show you as an example of what you can do with Ajax, where in this case we have a function that is triggered when the search button is clicked. And it goes back to the server, so this section here is the Ajax call. So it goes back to this URL, API person, search persons, then the search string back to it, and then returns the result. And the result, it's a JSON object in this case. I'm just going to show you the example here so you can see a more complex situation. So in this case, I'll actually show you the page itself. So in this case, you have this form where you enter some search string like a name, goes back to a database, it searches for the result, and brings back this data. And this is all Ajax. So the page was not reloaded. It's just a JSON object that it's being brought back. And if you want to see how this works a little bit, lower level, so we put the search string Ribeiro, and this is the data that actually comes back. So this is an example of Ajax calling a service, and this is how the data looks like. Okay, so this is a JSON object that brings back 4 records. One of the records is actually an image, an encoded image, base64, and it brings all the records that are necessary, that you need to process. So in terms of performance, in terms of usability, it actually makes it a lot better, a lot faster, and better performance when you're using it. So the examples that I showed use the get verb. So basically it's a method to just fetching some data. But you can also use this to update a record on the back end. And instead of using a get, you would use a post verb, and you would send, for example, a JSON object that you will send to the back end. We could, in an example, using the local storage case that Dan just provided, we could use a service that would, a JavaScript piece of code that would call a service that is a JSON object with some data and put it in the local storage, for example. It's just an example of how you could use this. And this is it's pretty much it. There's if you look at the document that I put together, let's see. Sorry. I think I closed the document that I didn't want to close. So in the end of the document, there's just a few references, just a few tutorials of how Ajax works. So you have W3 Schools that has this simple example, and it has a couple more complex examples. Tutorial S Point's another great example of what Ajax is and how it's working. There's a really good explanation about Ajax in Wikipedia, and another example on Segway Tech that provides a little bit more background on Ajax and a few examples of how it works. So very simple. I think in the next presentations we'll put together something that is more relevant to the project, or if there's questions, we could put together something that is more specific to Ajax. So you guys have any questions on this, or are we good?
No, you explained it very well.
Pretty cool.
Cool. All
I was
right.
enjoying looking at my image on your screen because my image on your screen is moving the opposite direction as my image on my screen.
Yeah. So I think we're good for today. Our Igor or Cassandra, do you guys want to any questions? You guys want to present anything, or?
I don't have any questions.
Okay. So I guess me and Dan will put the these examples in the GitHub repository, and you guys can take a look at them there.
All right.
Sounds good.
So what are we doing for Tuesday? Who's presenting on Tuesday? Well, I think Igor is the only one that hasn't presented yet, and Cassandra, right?
Yeah, I can present. What is left to present? What are the options remaining?
So Cassandra is doing the animations. I can't remember which. No, the DOM was presented by Bart. I can't remember from the top of my head.
I think DOM was covered by Bart.
Yeah.
And let me open it up so I can check it out.
So do we want a review of a topic already covered? Because we're going to have to keep covering things for the next few weeks.
Right, but I think we have some that we haven't covered yet. So.
Oh, what haven't we covered yet?
The animations, which is going to be Cassandra.
Animation.
I can do transitions and transformations.
Okay. All right. So I think we had a plan for Tuesday then.
Sounds good.
All right.
There's this awesome website I saw. It was Alice in Wonderland. As you scroll down the page, not only does the background image update, the text on the page scrolls to the next text. So the text kind of funnels down into the rabbit hole on the background image of Alice, you know, in Wonderland, Alice going into the rabbit hole.
Wow, that's pretty cool.
It was amazing. I want to see if I can find it again.
All right. I think we're good today.
All right.
See you Tuesday.
See you Tuesday.